Hello students, Science and Technology Part 1st, Chapter 1st, Law of Motion. Today we study equation of motion using graphical method. Students, Newton studied motion of an object and gave a set of three equations of motion. This related the displacement, velocity, acceleration and time of an object moving along a straight line. Suppose an object in a motion along a straight line, initial velocity u, it attains a final velocity v in a time t due to the acceleration a and displacement is s. The three equations of motion can be written as: equation is relation between the velocity and time is v equal to u plus at. The second equation between displacement and time s equal to ut plus 1 upon 2 at square. And third equation relation between displacement and velocity is v square equal to u square plus twice as. In this equation, by the graphical method obtained, try let us. Equation describing the relation between velocity and time. Look at this figure. In this figure show the velocity, the change in velocity with time of uniform acceleration of an object. The change in velocity with time of a uniformly accelerated object. The uniformly accelerated of a graph is a straight line. The object starts from a point D in the graph. The velocity is a u. Its velocity keep increasing after time t. It reaches the point B on the graph. That means जेव्हा वस्तू ही D या बिंदूपासून गतिमान होते, वेळेनुसार त्या वस्तूचा वेग हा वाढत जातो व ती ह्या कालावधीनंतर वस्तू B ह्या बिंदूपर्यंत पोहोचत असते. Initial velocity of an object is a u. It equal to OD. The final velocity of an object v is OC. OC. The velocity final of an object. The time t is equal to OE. The formula of acceleration A equal to change in velocity upon time. Velocity upon time. Change in velocity means final velocity minus initial velocity upon time. The change in velocity u is the change v is OC and initial velocity OD upon time t. Equal to CD upon t. CD equal to A into t. T is divided in this side is a multiply. Therefore, CD equal to 80 in equation number 1. But OC minus OD in final velocity minus initial velocity is equal to CD in this equation. Now, the parallel to y-axis passing through B. This will cross y-axis of E. Parallel to x-axis, passing through point D, this will cross the line BE at a point A. From this graph, BE is equal to AB plus AE. From this graph, BE is equal to AB plus AE. Therefore, V equal to CD plus OD. CO and BE is a parallel line. AB equal to CD and AE equal to OD. Therefore, V equal to AT plus U. OD equal to U. AT is the acceleration plus U is the velocity, initial velocity from equation 1. Therefore, V equal to U plus AT. This is the first equation of motion. This is the relation between velocity and time. Second equation describing the relation between displacement and time. Let's suppose, look at this figure. Let's suppose an object in uniform acceleration is A and it has covered the distance S with the time T. From the graph, the distance covered the object during time T is given the area of chord angle DOEB. The area of chord angle DOEB. Therefore, the area of chord angle DOEB. Therefore, S equal to area of chord angle DOEB equal to S equal to area DOEB. DOEB is DOEA is a rectangle and area of triangle DAB. Therefore, S equal to rectangle DOEA. The formula is length into breadth plus area of triangle. The formula is 1/2 into base into height. Height and dA is a base. But AE equal to U. U is the initial velocity and OE is equal to T and OE equal to dA is equal to time T. AB is equal to A small a T. From equation 1, AB equal to CD. This is a parallel. Put the value in equation. Put the value in the equation 1 of equation 1. Therefore, S equal to A into OE is a U. Equal to AE into OE. AE is a U and OE is a t plus 1 upon 2 into AB is a AT and DA is a time t. This is the Newton's second equation of motion. Is S equal to AT plus 1 upon 2 AT square. This is the second equation of motion. S is the distance, U is the initial velocity at time t plus 1 upon 2 acceleration times square. Equation describing the relation between displacement and velocity. We have seen that from a graph in figure we can determine the distance covered by the object in time t from the area of chord angle DOEB. The DOEB is a trapezium. The chord angle is a DOEB is a trapezium. So we can use the formula for its area. The area of chord angle DOEB is a trapezium. Therefore, A is equal to area of trapezium DOEB. Therefore, A is equal to the trapezium formula is 1 upon 2 into sum of length of parallel side into distance between the parallel side. So, A is equal to 1 upon 2 the sum of length of parallel side OD plus BE into distance between the parallel side. The distance between parallel side is a OE, but OD equal to U. OD equal to U. U is the initial velocity, and BE equal to V. V is the final velocity, and OE equal to T. Put the value in equation. Put the value in this formula. Therefore, S equal to 1 upon 2 into OD plus BE. OD is a U and BE is a V into OE is a T. But acceleration equal to change in velocity upon t. Change in velocity means final velocity minus initial velocity upon t. Therefore, t equal to v minus u upon a. In this equation number 3. Put the value in the equation number 2. A is equal to 1 upon 2 into OD plus BE is a U plus V plus T is a V minus U upon A. A is equal to V plus U in first bracket into V minus U in second bracket upon twice A. Therefore, twice A into S equal to V plus U minus V minus U equal to V square minus U square. V square equal to U square plus twice AS. This is the Newton's third equation of motion. Always remember, the velocity of an accelerated object changes with time. Change in the velocity can be due to a change in direction or magnitude of the velocity or both. Uniform circular motion. Next point. The definition of uniform circular motion. When an object moves with a constant speed along a circular path, the motion is called as uniform circular motion. For example, a stone in a string, or that of the point on a bicycle wheel when they are the uniform circular motion. If an object move along a circular path of radius r, taken time t to come back to its starting position, its speed can be determined using the formula given below. The speed formula is speed equal to circumference upon time. Speed is a v equal to circumference. Formula is a twice pi r upon time t. R is the radius of the circle.